Okay, so let's consider another problem where we have been given that there is a function and we have to check for the differentiability of this function at two mentioned points. This problem appeared in JEE 2012 paper 1. So let's have a look at this problem. So if you look at all the options, essentially it talks about the differentiability of the function at the 2 points. So what we'll do is we'll check for the differentiability of the function at these 2 points. So let us first consider the point x equals to 0, and we'll write the right hand derivative expression at this point, and we'll also write the left hand derivative at this expression at this point. So if we write the right hand derivative expression, we will have f of 0 plus h minus f of 0 over h. Okay, that is, now substitute the values of the functions over here. So f of 0 plus h will show as f of 0 plus h whole squared times mod of cos pi over 0 plus h, and then this will get divided by h. If we cancel out a factor of h from the numerator and denominator, so essentially we'll have this h, and we forgot to put limit h tending to 0. So limit h is tending to 0. So we'll have this h mod cos pi over, and h is tending to 0. So you'll observe from here that as h tends to 0, the term pi by h, it will go towards infinity. But if you take the cosine of, then you will find that this thing will always lie between 1 and minus 1. So in a sense, I can say that as h tends towards 0, this quantity, which is cos of pi over h, it will be varying in a bounded manner. So this particular thing will be something finite. Now this finite thing, when getting multiplied with h, which is going towards 0, so anything tending towards 0 getting multiplied with something finite, so I'm calling tending to 0, this will go towards 0. So we'll find that the right hand derivative for this particular function at the point x equals to 0 will be 0. In a similar way, we can write down an expression for the left hand derivative. So I'll write left hand derivative. This will be equal to f of 0 minus h minus f of 0 over minus h, and h is tending to 0. So this will look like h squared times mod cos pi over minus h and minus 0 over minus h. So this h and this h should cancel out. So eventually we'll get minus h times mod of cos pi over h. Now here we have used the fact that cos of minus theta is same as cos of theta. Okay, so this thing is gone, and we have just put a h over here. Now as h tends to 0, this thing will be again finite and bounded, so even this limit will go towards 0. So we find that the right hand derivative and the left hand derivatives, they are equal at the point x equals to 0, and hence my function is differentiable, and we'll say that the function is differentiable at the point x equals to 0. So from here I can check that possibly option A or possibly B could be my answer, because C says it is not differentiable at x equals to 0, so that option is ruled out. Differentiable neither at x, that also is ruled out. So now we'll check whether the function is differentiable at x equals to 2 or not. The function fx at the point x equals to 2. So we'll write the right hand derivative expression as f of 2 plus h minus f of 2 over h, and limit h tending to 0. Now we know that f of 2 will be equals to 2 square times mod of cos pi by 2, so that will be equal to 0. So we see that f of 2 is actually equals to 0. So now if we substitute the values, we will have 2 plus h whole squared times mod of cos pi over h plus 2, or 2 plus h. Let me write this over here. So this minus 0 over h. Now as h tend towards 0, we'll find that this expression cos pi by 2 plus h, it will tend towards cos, which will tend towards 0, and h is already tending to 0. So we'll essentially get an indeterminate form which will look like 0 by 0. So what we can do is we can convert cos pi over 2 plus h using the result cos theta equals to sine pi by 2 minus theta. So let me just write it down in this form. So this will give me sine of, we'll take the LCM and all, so we'll have this as pi h over 2 times 2 plus h. So my expression will now become equivalent to this. Now you'll see that as h tends towards 0, pi h by 2 times 2 plus h, this will tend towards 0, and therefore sine of that thing will also tend towards 0. And since you are approaching h from the right hand side, so h is tending towards 0 plus, so the argument of sine thing will be something positive, so we can remove the mod sign to get finally 2 plus h whole squared times sine of pi h over 2 times 2 plus h and by h. Now we'll have this expression which is looking like sine of 0 0 by 0 0 form. So for this particular thing we just need to replace whatever is in the numerator, same thing in the denominator. So my expression will now look like 2 plus h whole squared times sine of pi h over 2 times 2 plus h over pi h by 2 times 2 plus h, and we already had a h over here, so we'll keep it that way, and then we'll multiply by the same thing, so we'll have 1 over pi h over 2 times 2 plus h. So now you will see as h tends towards 0, this h and this h, they will cancel out, and this complete thing will now become equals to 1. Theta tending to 0 goes towards 0. One factor of 2 plus h will cancel out from here, and eventually we'll get pi 2 by 2. So this limit will become pi. So we'll say the right hand derivative for this function is pi. Now write the left hand derivative expression. So we'll write the left hand derivative as f of 2 minus h minus f of 2 by h tending to 0. So once again we'll do a similar thing that we did in the previous case. So 2 minus h whole squared mod cos pi over 2 minus h over h. So once again we'll replace cos theta by sine pi by 2 minus theta. So the given expression, it will look like as the left hand derivative equals to 2 minus h whole squared times mod of sine minus pi h over 2 times 2 minus h divided by h. Now you will see that h is a positive number, so there is a negative sign over here, so sine minus theta equals to minus sine theta. So if we remove the mod sign, we'll eventually get minus 2 minus h whole squared times sine pi h over 2 minus h, and this whole thing divided by h. So once again we'll just divide by pi h over 2 times 2 minus h, and we'll multiply by the same thing, and will this h and this will cancel out, this 2 minus h thing will cancel out with this far, so eventually we'll have this equals to minus of pi. So we have seen that the left hand derivative is minus pi at x equals to 2, and the right hand derivative equals to pi at x equals to 2. So from here I can conclude that the left hand and right hand derivatives are unequal to each other, and therefore the function is not derivable at x equals to 2. Hence we'll have option B as my right answer, which says that the function is differentiable at x equals to 0 and not differentiable at x equals to 2.